Hey everybody, welcome back to Calc 3 Online. Today I just wanted to do one example, and this example is going to involve the cross product. And it's like a problem that we did before where we're just writing the equation of a plane that does some specific things, but there are certain problems out there where if you have the cross product, it's going to be easier to write the equation of the plane or line maybe even. And your homework problems are all ones where I kind of think you should use the cross product to help you. So let me just show you how this is done. So in this problem, I want a question where I want you to write the equation of a plane that just passes through some point, 314, and contains the line of intersection of two other planes. And this picture down here, I think, kind of will help you see what's going on. So, and maybe make sure you understand why we're using the cross product is the big idea. So say this is the line of intersection between the two planes. You can definitely get the normal vectors for each plane just by pulling off the coefficients, right? And if you use your cross product of these two vectors, right, then you would get a vector that's in line with that intersection, right? Because basically it's summed up right here, which you can pause and read that if you want. But the idea is like this, line right here is in this plane down here, so it's perpendicular to that normal. And this line is also in that plane right there, so it's perpendicular to that normal. And the cross product is that tool that just gives us the vector that is perpendicular to the other two there. So we're going to do a cross product between the two normals to get one of our direction vectors. So we got ijk, and then the normal vector for, say, this plane is 1, 2, 3. And for this one, it's 2, -1, 1. And so if we do our cross product out, we're going to have 2 plus 3 times I hat. And then we're going to have minus 1 minus 6 for j hat. And then we're going to have plus -1 minus 4 for k hat. And if you simplify that all down, you would get the vector 5, 5, -5. So 5, 5, -5 is like this vector v right here. And that'll be one of my direction vectors. So my answer will be, I'm going to give it in vector form, which is really like the simplest way to write the equation. And so far we know a point that the plane goes through, which was just given already, right, 3, 1, 4. And we know one direction vector now. We know 5, 5, -5 is in line with the plane. To get the other one, basically imagine there's like our point 3, 1, 4 is up here in space or something. If you connected 3, 1, 4, so if we connected this point 3, 1, 4 to a point down here in the line, we could get another direction vector. So that direction vector would then be, in a different direction than the original one we just found right here that's in the line of intersection. And so then we would be able to put that in here and have our equation of the plane. So that's what we're going to do. To find a point, like one down here, in this line of intersection, basically we're going to solve a system of equations. So we know, based on this vector, that the what's an example? So we know z can be 0 at some point because We know it's not like parallel to z equals 0, like the xy plane, that this direction vector for my plane I want to write must eventually pass through the xy plane. So I'm just going to say I'm going to let z equals 0, okay? And then the blue plane that I underlined up there would reduce to x plus 2y equals 1. And the yellow one is going to be 2x minus y equals -3. And I just do this because basically what this point that I'm going to find is, I'm just forcing it to end in a 0 is the idea. And so now I just have a system of 2 equations. It's just easier than a system of 3, basically. So I can just, I'm going to probably do substitution. X equals 1 minus 2y. Then I'll take that and I'll put that in there. Here we would have 2 times 1 minus 2y minus y has to equal -3. I'm going to use a calculator and do some of this because I don't want to do it in my head. I get y equals 1. And then if y equals 1, then if I go back up to here, right, it would tell me x is -1, right? So that means I have like a point. Let's actually do a different color here. So I basically found this purple point, and I had sort of assumed that the z value was going to be 0, and I just found an x and a y that would match up with that z value. So I found x to be -1 and y to be 1. Now, you have a point, and you have another point outside the line, 3, 1, 4, and you could just find this vector by doing subtraction, and that would be, basically the problem's over. So we'll just do 5 minus negative, no, not 5, sorry. 3 minus -1 is 4, and then 1 minus 1 is 0, and then 4 minus 0 is 4. So I just did, this minus this, and I found that vector. And that would have to be another direction vector for my plane. And this is a perfectly good way to write the answer. That's an equation of the plane. This is like S and T, right, scalars. Basically, it's just letting you, again, go forever in that direction, this blue vector direction, and then forever in that line of intersection direction.